This is IAT806 Lecture 2.3. In this segment of Lecture 2, we will talk about getting and using mouse data using a couple of techniques. First, by accessing mouse variables, and second, by using mouse callback methods. So let's get started. So the first method of getting mouse information is to use mouse variables. These are variables that are automatically filled by the processing system with the current information as to where the mouse is located. So those variables are mouseX and mouseY with a capitalized X and capitalized Y. These are variables that automatically contain the current mouse location. You can also get the previous mouse location, that is to say the mouse location that was measured during the previous draw call, and those variables are named pmouseX and pmouseY for previous mouseX and mouseY. Every time the draw function is called, just before the draw function is called, mouseX and mouseY are read from the actual mouse device, so to speak. One important point to bear in mind is the mouseX and mouseY, pmouseX and pmouseY, are in the coordinate systems of the draw window. So when you have the mouse located in the upper left corner of the draw window, mouseX and mouseY will each be 0. And as you move the mouse to the right, you'll get increasing mouseX values, and as you move the mouse downwards, you'll get increasing mouseY values. Another variable that you might be interested in is mouse pressed, and this is a Boolean variable that is true if a mouse button is pressed down. That is to say, if you press any mouse button, mouse press is true if during the draw call, at the start of the draw call, the user had the mouse button pressed. You can query which button was pressed by accessing the mouse button variable, and it returns, that's an int, and it returns the value left, right, or center, depending on which button is held down at the time that draw was called. So now what we'll do is just show an example of using mouseX and mouseY in a running processing example. So let's just go there. So here we have a program similar to the one we used before, where we have setup, setting the size of the window to be 400 by 400, and this time a background color of 128, which is a middle gray. We also have two variables that we're declaring mid-X and mid-Y. We're not really going to use these much, but mid-X is the middle of the drawing area along the X dimension, and mid-Y is the Y dimension of the middle of the drawing area. So what we're going to do first in draw is we are going to set the background to be, that should be 0, and draw an ellipse at the location of the mouse. So let me just stop there and you can think about what's the result of that going to be. Okay, let's press play and see what we get. And as you can see, right now you get a black drawing area because we're repeatedly clearing the background to 0. But when we move the mouse into the area, we get a little dot that's following us around. And that is because we're drawing a 5 by 5 ellipse. And it is following the mouse, mainly because there's a little bit of lag especially during the video recording, of interacting with the processing area. So there's a little bit of lag between where the mouse is located according to where the video capture puts the mouse cursor and where processing responds over the course of recording the video. So let's stop that. And now do something else. What we're going to do is draw a line segment between mouseX and mouseY, the XY location of the mouse at the current drawing step, and the previous location, X and Y, of the mouse location. So let's press play and do that. And right now we don't really seem to get much, mainly because every time we do this we clear the screen, and also the drawing area, the color of the line segment is black, so we can't really see a black line on a black background. So let's set the background to be 128. Stop and restart it. And we can see it's no longer black, but now gray. And we can see just a little sort of line segment peeking out at the end, kind of in the opposite direction of the movement of the mouse cursor. Let's, instead of clearing the screen every time, Let's not do that at all. So we're going to clear the screen once during setup, right there, and then not clear it at all. And what will happen is each ellipse and line that we draw will stay on in the drawing area, and every subsequent draw call will draw more stuff onto the drawing area. So let's stop that. Start that again. And right now, we see a mid-gray background. And as we move our mouse around, we can see that we're getting a little dot and a line segment joining one dot to the next. And I'm going to just leave that. You can see that horizontal line has dots widely spaced. And the reason why it's like that is I rapidly move my mouse from the right edge to the left edge. And the result of that is you see very long line segments there. Whereas here in the bottom left, right here, you can see just along this area here, we have, very short line segments and dots drawn very close to each other. In fact, as I'm drawing here in the bottom right corner, the little ellipse has a stroke of black drawn around it. So essentially, I'm mostly getting black drawing the strokes because the strokes are drawn after the fill. Okay, so that illustrates the use of mouseX and mouseY that you can read anytime in Draw, and will tell you the current mouseX and mouseY locations, and it will also tell the previous mouseX and mouseY locations that were captured in the previous call to draw. We haven't used mouse pressed or anything like that. We haven't used that Boolean variable, because what I want to do now is talk about mouse callback methods. These are methods you define that processing is expecting, and if you define it, it will call it at the appropriate time. So what happens is these methods, these callback methods called mouse pressed, mouse released, mouse moved, and mouse dragged are called automatically by the processing system if the user has pressed the button, released a mouse button, moved the mouse button while pressed, I believe, and dragged the mouse, that is to say, held the mouse button down and moved the mouse while the button is pressed. So for example, mouse pressed, if the mouse button equals left, then we can have something that says left mouse button was pressed, and then execute the loop call. So this gives an example of where you would reactivate automatic calling of draw. How that can possibly be done. You reactivate automatic draw calling by calling loop within a callback function that responds to user inputs such as mouse pressed, keyboard being pressed, and so on. We're not going to really do this too much, but I just wanted to show you that it is possible in a call like this. What I'm going to do now is switch over to the processing application. And here I've expanded the processing window a bit so you can see more code. And what you can see here is a draw function in which I am querying the mouse pressed variable. So if mouse pressed, then what happens is I set the fill value to white, and then I draw an ellipse and the line segment as before. I do not have a background called in draw, so all of my drawing will be drawn on top of the previously filled color, which if I will scroll up now, you can see I set the size in setup to be 400 by 400 as before, and the background color to be 128. Let me scroll down again, and we can see the rest of the program. So the rest of the program is two callback functions that I've created, and I know what the name of it is because I just finished talking about it. So the mouse pressed callback function, what it does is it sets the fill color to be 0 and 280, a kind of a middling green, and draws an ellipse at the current mouse X and Y location, and the ellipse size is 10 horizontal and 20 vertical. The mouse release function, which is called automatically when the mouse button is released, sets the fill value to 200, so red, also draws an ellipse. This one is 20 wide by 10 high. So let's just press play and see how that looks. So here is our gray window again. And now nothing is drawn because this variable over here, mouse pressed, I hadn't been pressing the mouse while moving my mouse around above the gray window. Because I hadn't pressed or released the mouse, none of these callbacks had yet been called. So let's go back to the drawing window when I'm moving my mouse around. And you can see the mouse cursor is moving around. Now I'm going to press the button, and you can see now that there is a green ellipse there. Now let me move the mouse around, and you can see it is now doing the thing that is shown in the draw call, setting the fill color of whatever I draw to be 255, and drawing an ellipse and a line segment between the current and the previous mouse location. And you recall, if I move the mouse rapidly, I get these long line segments from one location to the next. I have been holding the mouse button all the time while I'm talking, and so you don't see anything else other than this chain of dots connected by line segments. Now let me release the button. There it is. And I get a red ellipse being drawn that's 20 wide and 10 high. So let's do a few more of these. Press the button, release the button. Press the button, release the button. Press the button, release the button. Even if I move my mouse cursor outside the window, I get processing continues to record where the mouse button is, and once the mouse values are within the drawing area, line drawing continues. So I can get sort of funny values of mouse X and Y location if the mouse cursor is located outside the window. Okay, so that pretty much is an example of how to use callback methods with a very brief piece of code, and how to use the mouse variables. And these are sort of the basic ingredients that you need to be able to do interactive programs using the processing system. So just as a final note, one of the things that's always important is to practice reading code. In addition to writing code, it's also very important to learn how to read code. And now it might seem simple, but it's often the case that reading of code is actually a little bit harder than writing code. So by all means, write code, experiment, do things like I showed you just now, but also reading code reveals new programming constructs, strategies and techniques, and style. Okay, so that's it for Lecture 2.3, Mouse Data.